All right, STAT1150. My name is Dr. Darbro. I will be the person creating the instructional videos for this class. There's a possibility that you may take the class from me. There's also a strong possibility you may take the class from someone else. So uh, uh, it is important, I think, to identify your instructor and stay in touch with them, because they're going to be the person that's going to be assigning your final grade. But if you're taking this class from someone else and you just feel the need to reach out to me, then email me. I'll probably answer, but I'll probably tell you that that's a question for your instructor. They're going to be the ones, again, getting the final grade. They're going to be handling office hours, tutoring sessions, and so the textbook we're going to use is all right, welcome to STAT 1150. My name is Dr. Darbro. I'm going to be creating the instructional videos for this class. Just a little history. I've created this class once before. We've actually offered it online for about 10 years, but I realized that there's some things that need to be updated. And one of the primary changes, one of the primary focus that of doing of editing the course is I want to make the instructional videos shorter. Previously, I tried to align the instructional videos with like what a face-to-face class would be, about an hour. And I found that that was just too much. Although I may be a legend in my own mind, I realize I'm not entertaining enough to keep your attention for an hour, hour and 15 minutes. So most of the videos I'm going to try to keep them around the 15, 20-minute range at tops. So again, I'm Dr. Darbro. The textbook that we're using is Elementary Statistics by Triola, 14th edition. You're going to hear me a lot, so I guess it's kind of good to start out, tell you a little bit about me. I received my bachelor's degree from Morehead State in '89 in mathematics. 1994, I received my master's from University of Kentucky, also in mathematics, and then my PhD from the University of Kentucky in statistics, measurement, and evaluation. Completely kind of shifted gears from my bachelor's and my master's into my doctorate. Experience as I'm posting this video today, in my 28th year at Shawnee State. I've taught this class so many times. The first time I taught it, we were still in the quarter system. It was actually Math 150 at that time. It was a 4-hour course. And then we transitioned from quarters into semesters, and we taught it as what we call Math 1500. And then it transitioned to Stat 1500. And now it's Stat 1150. Different title, same content for the most part. I've also taught a lot of online courses. Somewhere along the line, I'll probably uh, tell you a little bit about these experiences. I was very reluctant to teach this class, very hesitant to teach this class online because I didn't think it would work. And our provost, who was with us a few years ago, Dr. Todd, stopped, and I always liked Dave, and he asked me if I'd teach it, and I couldn't say no to him. And I taught it thinking it was going to be a complete failure. And actually, I was surprised after about 3 years when I compared the success rates for the students in my online classes versus my face-to-face classes. The success rates were just a little bit higher for the online classes. Now, there's a caveat to that. Online classes don't work for everyone. If you're not disciplined, if you don't have the self-discipline to do certain things, then you should really strongly uh, consider switching to a face-to-face class. But if you're taking the online class and you are self-disciplined, I think the key points in being successful in the online class is to approach it as if you're taking a face-to-face class. In other words, attend class. That means you must watch the instructional videos. Um, that's equivalent to attending class. But the difference is, instead of attending class, as example, maybe from 1 o'clock to 2 o'clock on Monday, Wednesdays, and Fridays, you can attend class whenever it's best for your schedule. but nevertheless, you're going to have about that 3 hours per week that you have to uh, set aside, be disciplined enough to watch the videos because, I'll be honest, I'm very transparent here. I'll always be honest with you, but I won't always be forthcoming and transparent. But I will in this case. I lose interest in students if I realize they're not watching the instructional videos, because that tells me you're not giving me an opportunity to teach you anything. So um, just suck it up and make time to watch the videos. And if you're busy, say you got a lot of family responsibilities and something's going on, maybe you got a heavy workload, then maybe you should drop the class and take it at a different time. Uh, Next thing, take notes. When you're sitting watching the instructional videos, take notes because you're going to need them. First of all, I'm going to throw so much content at you over this class that just storing it mentally, if you will, is not an option for most people. So you're going to use your notes to prepare for the exams. You're going to use your notes to prepare and complete the assignments. And most classes will allow you to use a cheat sheet on the exams. So then you can use your notes to kind of collapse down to the notes that you think will help you be successful on your exams. So again, approach the class as if it's face to face and watch the instructional video so I can teach you something. You're going to see alignment, a correspondence between what I teach you in these instructional videos and what you do on your assignments, and then what you're asked to do on your exams. So let's jump into it. Statistics is the science of collecting, organizing, and analyzing data. Another way of saying that is we prepare, we analyze, and then we conclude. The collection preparation phase, extremely important. Otherwise, we get into what's called a garbage in, garbage out. If we, excuse me, let me get a cup of coffee here. If we collect data that isn't representative of the group we're trying to make a statement about, then we get garbage data. And we can do the best analysis, use the fanciest formulas, the most sophisticated and complex models. But if we're dealing with garbage data, even the most sophisticated models will end up in garbage results. To, Many people at this level think that we're going to sit around and work complicated calculations and use formulas that are insane. The one I'm giving you there is the covariance. We're not going to do that. That's not what this class is about. I teach a class where that's what this is about. I teach, the graduate level courses here at Shawnee State. We get into things like this. We don't get into the mathematical calculations. If we want to find a covariance, I'm going to teach you how to find it using StatCrunch, the statistical software package that comes with my stat lab, which we use, which is a Pearson product. And then I'm going to teach you how to interpret and comprehend what the covariance is telling you. But we're not going to reuse all these fancy formulas and complicated calculations. Talk a lot about data. Data is just the collection of observations, measurements, religious affiliation, ACT scores, high school GPAs, whatever kind of information that we collect. Could be survey responses. We call that our data. Population is the entire group of subjects, elements, dogs, cats, trees, whatever it may be that we want to make a statement about. Typically, we think of our population as being this large group. In fact, it is so large that we can't take measurements on every single person, subject, element, dog, cat, whatever, from our population. So we do what's called, we take a sample. And we use that sample to make an inference about the larger population. We see this all the time, at the times around our 4-year elections, specifically for president. leading up to the election, there are all kinds of polls out there to see who's leading, right? Well, what we're doing is we're taking a sample to make a statement about the population. The population in this case would be those voters who are most likely to vote in the presidential election. There's a lot of caveats, a lot of things to consider there, but we'll get to those in due time. Population versus a sample again. Again, the population is the entire group. A sample is just a sub-collection of the entire group. The data we collect from a population is called a parameter. The data we collect from a sample is called a statistic. All right, pump the brakes. Get this one in your notes. What we do in statistics is we use a statistic to make a statement about an unknown parameter value. The parameter value represents the population. It's unknown. We want to estimate it. So we use data from our sample, which is called a statistic, to make that estimation. And we'll use things like confidence intervals and hypothesis testing. We'll get into type 1, type 2 errors and power. Lots of stuff to be learned. But right now, let's just understand the foundation, the core of what we are trying to accomplish here. We're trying to make a statement about a population where a value from that population is unknown using the information from a sample. So here's a pretty good example. 410 HR folks were surveyed, 148 of the 410, which is 36.1%. Said that they would disqualify a job candidate based on information found on social media posting. I reflect on this, and I remember back when social media just I remember the day that I actually created my Facebook account. Now, it's been quite a few years ago, and we were snowed in, and we were bored, and everybody kept talking about this Facebook, and I thought, well, why not? So my wife and I created one for each of us, and we still have them today. I didn't understand back then, I don't think most people did, how what we post on social media can affect our lives, affect, relationships with family members, affect potential job applications. So anyway, what can we conclude here? Well, our population is all HR professionals. We used these 410 as our sample. Now, what can we conclude here? Well, in my opinion, based on this information, we can't conclude anything. Is 36.1% a statement that I can put some quote unquote truth into? I don't know yet, because I don't know how these 410 HR professionals were selected. Were they selected through a voluntary response sample? So did some HR organization say, hey, we're getting ready to do this study. If you're interested in participating, respond to this poll. Well, when I typically see a volunteer response sample, I immediately just write garbage across it and don't and put absolutely no faith at all in the results. I know from my background in statistics that volunteer response samples evolve into bias, which is deviation from the truth. Internet polls, mail-in polls, call-in polls, we see all kinds of goofy things on media trying to gather data to make a statement about some group of people. So I hope if I do my job, and I will, if you do your job as a student and watch the videos and let me teach you something, you're going to know by the end of this class that voluntary response samples lead to garbage studies. Now, let's take a look at a voluntary response sample. Which one of these do you think is best? Now, the first one, I'm not going to read it to you, but you can see that for some reason, someone is interested in whether or not the United Nations headquarters should remain in the United States, and they want to know how I guess, people from the United States feel about this. So Nightline asked viewers to call with their opinion. They got a huge response, 186,000 people, and 67% said that the United Nations should move out of the United States. I read that, and first of all, a lot of people may be impressed that it's a super large sample, 186,000. So we should put a lot of kind of hope into the result. Uh, you know, I guess, quote unquote, kind of trust it. I don't. When I see ask viewers to call, that I think voluntary response sample, that leads me to think garbage study. The second one says a survey and independent survey, I'm sorry, in a separate and independent survey, 500 respondents were randomly selected. When I see randomly selected, even though there are only 500 respondents, I see a study there that I'm able to put some level of faith in, trusting the results. So, second one, I would put some faith in. The first one, I would, if I could, I would write just garbage across the top paragraph. Once we design our study, the final step, and again, I'm just giving you the highlights. You got to stick with me through the entire course to get all this stuff. But one thing we talk about in statistics is called statistical significance and practical significance. Now, I'll be completely transparent with you here. I think the author is getting the cart in front of the horse, talking about statistical significance at this point, because I think there's a lot to be learned in terms of like p-values and sampling distributions and different things before we can truly understand statistical significance. But he has defined it in such a general way that I'm okay with proceeding. So what he says here is statistical significance is achieved in a study if the likelihood of an event occurring by chance is 5% or less. So that's probably not going to have a context to you. So completely understanding this definition will evolve over time. But for now, if you can just get those words kind of tattooed to the brain, we can actually work with this uh, uh, to examine the difference between statistical significance and practical significance. Speaking of, an example of statistical significance versus practical significance, let's say that we have a study that an ACT prep program. I have two daughters now who are seniors in high school, and they, interesting, there's 35 days difference in their ages. They're both adopted from China, in case you're trying to figure out how I created kids 35 days apart. But anyway, they're applying to some pretty prestigious universities, and they've taken the ACT and SAT quite a few times. I was always interested in maybe these ACT prep programs where you go, pay thousands of dollars with this, person that's kind of guaranteeing that they can raise your child's ACT score. So let's say that just as an example, the 121 students participated in this ACT prep, and they gained zero point 0.4 points on the ACT after the weekend prep program. The gain would probably be statistically significant, again, if it suits the definition from the previous screen, so therefore it's not likely to just occur by chance. But I think I would argue that there's no practical significance here, because a gain of 0.4 points probably isn't going to affect the overall ACT, since the ACT is reported in integers, 32, 33, 34. I've never seen an ACT reported as like 28.2. Same thing could be said for maybe a weight loss program. Maybe people go through a weight loss program for like 6 months, and they lose 1 pound, and because of different things, power and sample size and all that, we get statistical significance. Well, is it really practical significance to go through all the crap of a diet for months only to lose 1 pound? Well, I'll let you decide that. I know how I would feel. Um, all right, that's it. Again, welcome to Stat 1150, and let's get this going. Take care.